Okay. So were there any questions about last time, what we talked about? Any issues? Tried the homework out of the packet. Any questions? No? Okay. All right. So let me bring the roster up here so I can call people. So today is going to be all about lines, okay? That's all we're going to talk about today is lines. And so we're actually changing the order a little bit from the calendar. So today's homework assignment is actually going to be problems that I give you here at the end of class, and that's what you're going to do at home. So you're not going to do anything out of the packet, all right? All right, so let's get down to business. Let me make sure I can see how far I can go over here. See, right around here. And so right around there. Okay, so we've already studied, right? So I'm going to say here, recall from what we did in the last couple of days. We've been solving linear equations, right? That's what we've been doing. And when we looked at a linear equation, here's what it looked like. It was something like 3x plus 1 equals x minus 7. There we go. That was an example of a linear equation. I said, okay, what makes it a linear equation? Oh, well, we have an equal sign, and then we have a variable, and it's raised to the first power, right? That's a linear equation. What we're going to talk about now, lines, actually falls into a different category. These are called linear equations in two variables. In two variables. And the key is that we have two variables now. We still have an equation. It's still linear, but now we have two letters instead of one. So when we were doing these, if you remember, there was actually three possible things that could happen when you got an answer. You could have, first you could just get a number as an answer. So maybe you get like, okay, x equals 2, all right? Or you could get, also, I think we said an infinite solutions, right? Infinite solutions, right? Infinite solutions, or we could have no solution. No solution. Those were the three different possibilities when we're dealing with a linear equation. Here with a linear equation in two variables, everything is different, okay? Everything changes. We no longer have this happening. So let's look at a basic example first, and then we'll talk about why it's not that anymore. So I'm going to start with something very simple. If I write x plus y equals 4, right? We have an equation, right? It's linear in the sense that when we look at the variables, the power on those are ones, even though we don't write them. And there's two variables. So we have a linear equation in two variables. And the question becomes, what are the solutions to this? Or what is the solution to this? And when you look at it, you have some freedom here, right? You can choose different values of x and y to make this equation true, right? For example, I will just go around the room today. Can you give me an x and a y? What was your name again? Corwin, if you don't mind when I call on you, say your name. So I'm going to try and do like, with these masks, it's hard, but Corwin, give me an x and a y that would make this true. 2 plus 2. 2 plus 2. So if Corwin is saying if you let x be 2 and y be 2, then that would be a solution. Everyone agree? Go ahead.
Oh, you mean my name?
Both.
Oh, okay, Alicia.
Alicia. 3 and 1, okay. And that would work, right? 3 and 1, 3 for x, 1 for y. So look at, remember, over here we had like one answer, we had an infinite number of answers, which meant you could plug in any x you want, or we said no answer, where there's no x you could ever replace that with, no number that would ever make it true. Here, we've already gone through and we have two answers, right? Two different answers. Go ahead. You want to give me another one? Okay. 4 and 0. By the way, would anything change in this equation if I switched these? Like if I made the 1 the x and the y the 3? Wouldn't change, right? It would still be the same answer. In this one also, if I switch the order, it would work. Okay? Let's go one more. What was your name? Kylie, that's right, Kylie. I saw that you sent that. I will take care of that, okay? I'm going to actually force you to do something. Can you give me a solution, an x and a y that works, where one of them is negative? 6 and negative 2, right? So if you put 6 here and negative 2, we get this. So look, we could just do this all day long, right? We just keep going around the room. We could do that until we die, right? We would never run out of possible answers. You agree? We can never run out. So there has to be some way to somehow represent these answers in a way that kind of makes maybe some visual sense to us, because there's an infinite number of answers, right? So that's what we're going to try and do. We're going to try and somehow represent all of the answers to this equation visually, and to do that we are going to wind up drawing what would be called a line, right? That's what a line is. So what we do is we do this. We draw this x and y axes like this. And I should also point out that there's an infinite number of answers here, right? But not every combination of numbers works, right? Like you can't do 2 and 3. That wouldn't work, right? So even though there's an infinite number of answers, not every single pair of numbers would be a solution. So we're just interested in the ones that are a solution to this. So the way we do this is we say, okay, this is visually going to help us understand what each of these pairs are, right? So this pair right here, x2, y2, we can write it in a set of parentheses with a 2 and a 2, understanding that this first number is always the x and this second number is always the y. Okay, we call this an ordered pair. Ordered pair. Pair because it's two numbers, ordered because the order actually matters. All right, so 2, 2. So what I do here, and I know a lot of you have seen this, so I just go out on my x-axis, I start marking 1, 2, 3, and then on the y-axis I go up 1, 2, 3, like that. And then I just put 2, 2 out there. So that means I'm going to go to the right 2 and up 2, and I'm going to put a dot. So this dot right here is a visual representation of the solution, a single solution to that linear equation. All right? That's a visual representation of that one answer. And then I could keep doing this for all these, right? The next one would be 3, 1. So that means I'm going to go to the right 3 and up 1. And then I'm going to do the next one, 4, 0. Which was here. Oh boy, that's not very good. So 4 zeros there. And then, was it 6, negative 2, right? That's what you said. So if we go out 6, here's 6, and we go down 2, right there. So when we look at these answers, right, when we look at them, we kind of notice something, right? They all lie on a line, right? They all lie on a line. And so when we draw the line connecting these together, it turns out that any point that you could ever pick on this line should be a solution to that equation. It should be, right? Now, I didn't do a very good job here, but can you tell me what point this looks like it is? What's that point right there as an ordered pair? 0, 4, right? Let's just check it. 0, 4. Does it work in here? It does, right? So when you see a line, okay, when you see a line, you have to understand that the line is actually made up of a bunch of dots. That's really what the line is. And all of those dots represent answers to this equation. Is that clear? As we move on in this class, we're going to study things that are not lines. And when we study things that are not lines, we don't have this behavior, right? Okay, so all linear equations in two variables are going to be lines when we draw them, all of them. So what we need to get good at is me giving you an equation and asking you to draw me a line, all right? Questions? So we talked last time, right, about anytime you draw a line that we talked about the intercepts, right? That if you have a vertical line, it has to hit the x-axis, but it doesn't have to hit the y. If you have a horizontal line, it has to hit the y, doesn't have to hit the x. But if you have any sort of tilt to the line, it's got to hit both the x and the y. So we called these points where it hits the x-intercept, and then this point would be the y-intercept, right? The x and the y-intercept. I'm going to label this point right here. This is the point 40. Okay? All right, so I want to point something out about the intercepts. For the x-intercept, anytime you do an x-intercept, do you all agree that the y value will always have to be 0? If we're talking about an x-intercept, the y would have to be 0. Yes? Because you're on the x-axis, so you're not up or down, so your y would have to be 0. And over here, if you're talking about an x-intercept, did I say y-intercept? Sorry, I said x, okay. So we're talking about a y-intercept, you have to hit the y-axis, right? Then your x would have to be 0. Now that's important because we're about to learn, there's 2 ways to graph lines. There's 2 ways, right? There's 2 methods. And the first method that we're going to do relies on you understanding that anytime you have an x-intercept, the y-coordinate must be 0. Anytime you have a y-intercept, the x-coordinate must be 0. All right, let's do something here. Let's get down to business here. So there are 2 methods to sketch a line. The first method is called the intercept method. And the second one is called the slope intercept. I'm just going to put INT, slope intercept method. All right? Those are the 2 methods we have to sketch a line. I'm going to teach you both. And then when we have our test, our next test, I'm not going to tell you which one to use. You're going to be free to use whichever one you want. But there are advantages and disadvantages to each one, right? So sometimes the intercept method's better, quicker. You won't make as many mistakes. Sometimes the slope intercept's better. Okay, it's just really kind of, you have to look at the problem and see. Last thing, before we do this. If I tell you to draw a line, okay, if I tell you to draw a line, you must have 2 points, right? 2 points define a line, right? 1 point is not enough. You just have 1 point, there's a million, an infinite number of lines that goes through 1 point. But if you have 2 points, then you have uniquely defined a line. So if you're ever trying to sketch a line, all you need is to find 2 points. If you have 2 points, you're in business, right? You draw the line. So for both of these methods, our goal is going to be to find 2 points on the line. 2 solutions to the equation. So let me give you our first example. Let's do something like this. 3x minus 4y equals 12. And I want us to, the instruction here is to sketch this line. So you look at this. First thing you have to look at and understand and notice is that it is an equation, right? 2 variables, linear. So you know that this is a line. You have to know that just by looking at that. Understand? So we're in this category, and now we're going to do the intercept method. So here's the way the intercept method works. It's real simple. First thing we're going to do is we're going to find the x-intercept. Okay? We're going to find the x-intercept. We're going to find where this line hits the x-axis. Now, what did y'all tell me just a second ago? I'm going to go off camera here, but I drew this. And you said that if I have a line, wherever it hits the x-axis, what did you tell me about this here? What has to be true?
The y has to be 0.
The y has to be 0, right? The y has to be 0. So to find the x-intercept, what I'm going to do, the very first step, is to set y equal to 0 in this equation. The reason is that I know that the x-intercept has a y-coordinate of 0. So I'm going to set y equal to 0. and then solve. That's the procedure. That's it. That's how you find the x-intercept. You set y equal to 0 and solve the equation. So I'm going to write the equation down. 3x minus 4y. Well, I don't need to write the y again. So I'm going to write this equation down. I'm going to replace the y with 0, like that. And that really has the effect of killing off that minus 4, right? So all you're left with is 3x equals 12. And now, who's going to make me happy and tell me what you're looking at there? What is that?
X equals 4.
That's the answer. But what is that? It is. Just forget all this shit. Just look at this right here. What is that? What is this? It's a linear equation in one variable, right? Which we already know how to solve these. Do you see that? Like, we took this bigger problem, right? And we're trying to figure out what the x-intercept is, and what it boils down to is, can we solve this little linear equation? And we know how to do that. Here we just isolate the x, right? So we divide both sides by 3. Okay? Divide by 3, divide by 3. You get x is equal to 4, right? So as an x-intercept, as a point on the graph, we know that the x-coordinate's 4 and the y-coordinate's 0. That is our x-intercept. So this is our first point, right? That's our first point that we need. And now we just need one more, right? So to get the second point, I'm going to go find the y-intercept. So to find the y-intercept, let's see here. So Ashley has answered right, and Alicia, is that right? And then Kylie and Corwin. There we go. Okay, how about Allison? Where's Allison? No Allison? The other Kylie. How are you doing? Good? So I'm going to ask you, do you understand what's going on? Yeah. Okay. So I'm going to ask you here on this y-intercept, if this is what we did to find the x-intercept, right, then what do you think we're going to do to find the y-intercept? Yep. We're going to set the x equal to 0, right, and then we're going to solve that. So let's go ahead and do that. Do you want to tell me what this is going to be? Just if I write down the equation, I'm going to write 3, then what? 0 minus 4y equals 12, right? And then this is gone, yes? And now you have, again, a nice little linear equation. Now, yes, your variable is y, but who cares? It's still a linear equation. It's one variable, first power equals, divide both sides by 4, you get negative 3. Is that all right if I don't show that step? Dividing both sides by negative 4? So we get, as a y-intercept, the x was 0, right? The x was 0, and the y is turning out to be negative 3. And that's it. We have 2 points. Once we have 2 points, we go draw it. All right? So I'm ready to draw this now. So when you draw this, you just, it doesn't have to be perfect. You don't have to have graph paper, okay? Just enough to be able to give me an idea that you know what you're doing here. So first point is at 4, 0. So I'm going to just go like this. 1, 2, 3, 4. Here's 4. That's the x-intercept, right? So I'm going to put a point here. And then the other one is at 0, negative 3. That means you don't move left or right, but you come down 3. So 1, 2, 3. Mark it, negative 3 there. And then just draw a straight line. As straight as you can get it. It doesn't have to be perfect. There you go. There's the graph of the line. So let's see here. Kylie. Jose? No Jose? I don't think Jose's here anymore. Garrett? How you doing, Garrett? Good, good. Garrett, you understand, Garrett, that every point on this line is a solution to the, it's gone, to the equation we had? So having a picture of this line is somewhat useful in this sense, right? If I ask you right now, Garrett, if I asked you, if I plug in x equals -3, what was the equation? It was 3x minus 4y equals 12, right? If I ask you, Garrett, hey, x equals -2, y equals 5, can you tell me quickly whether or not that's an answer?
Yes.
You can tell me?
Well, I can't tell you the answer, but it is one.
So you think that if I plug this in here, it's going to be true?
Maybe not.
Maybe not? So why no?
Because the x is -2.
-2 and the y is, which puts you where?
Somewhere else.
Up here, right? Right? Do y'all see that this right here would be to the left 2 and up 5 up here, and that's obviously not on this line? So it is useful to have a line because it actually gives you a visual idea of like the things that don't work, right? Like if I ever have something over here, it's not going to work. And over here, your x's would be negative and your y's would be positive, wouldn't they? So if I ever give you a negative x and a positive y, not going to work. And we can tell that from the picture. That's maybe not so obvious when you look at that, right? I think if you just look at that, you're like, there's no way you come up with that idea without the picture. Am I making sense? Questions? Okay, so this was our first one. This was like a little baby one. Let's try a harder one. It's not like they get much harder, but what do you think I can do to make it harder? Fractions, right? That's always what you can do to make things harder. Throw fractions in there. Y'all ready for some fractions? Let's do some fractions. So how about this? -3/8 x plus 2y equals 1/4. I want us to sketch this. All right. All right, so the first thing you have to do is you have to realize you're looking at a linear equation in two variables, right? So you have to know this is a line, which it is, good, okay. So let's go after the x-intercept first, right? So if I do the x-intercept, so I'm using the intercept method. If I do the x-intercept, I'm going to set y equal to 0, right? So let's see. Alexis, are you here? Raymond?
Yes.
Yes, sir. Okay, what do you think, Raymond? Take me through this. What are you going to do for this first step?
You said y equals 0.
Okay, so it'll be -3/8 x.
Put the 2 and then the 0 in parentheses.
Yeah, so you can write that plus 2 times 0, or if you don't want to do that, that's fine. If you just mentally know that that's gone, right, then you could just go right to equals 1/4. Totally up to you, I don't care. I'm going to put it here just to be thorough. Okay, that's what we're doing here. And then now we have -3/8 x equals 1/4. Okay, Raymond, that is a linear equation. And we spent at least a day or two on doing these, right? So Raymond, how would you approach this?
I would take the -3/8 over to the other side and flip it and multiply the 1/4 to -3 over, or -8 over 3.
Okay, so you're going to multiply both sides by the reciprocal of this number.
Right.
Okay, so that is something you know. That's good. I mean, that's not something I talked about in this class, right? That's not the way I proceeded with anything. But if you're comfortable with that, that will work. Let me do it, and then we'll see if everyone like freaks out. Anytime you have a fraction in front, you want to get rid of it, you can multiply by what's called the reciprocal. So I multiply the top by 8, the bottom by -3. It's just that fraction flipped over. Whatever you do there, you must do here. Okay. You see what's going to happen over here? Was there a question there, Garrett? That's exactly the same as dividing it by -3/8. Same, it has the same effect. Yep. So the 8's cancel, the negative 3's cancel, and you're left with x here. And then on this side, when we multiply fractions, remember you go straight across, right? So we would get what here? 8 over negative 12, which you could reduce, right? 4 goes into both of those. So your x-intercept is, watch the way I write this, negative 2/3. Remember when we talked about this at the very beginning, that if you have a negative on a fraction, the negative can be on the bottom or the top or out front. They're all the same. So I decided to put mine, I don't know, kind of up on, whatever, it's out front. There. Negative 2/3 is our x-intercept. Now, let me just show you a different way you could do this. Okay? If you're a person who likes to do procedures, then you would clear the fractions first. Right? That would be the first, this is a linear equation, you clear these fractions. So I multiply this side by 8 and this side by 8. Okay, so when I do it on the left, I get negative 3x. Over here, the 8 goes on the top, because it's really like 8 over 1. 8 over 4, this is 2. You all see that? And now divide both sides by 3, negative 3, and you get the same answer. You see that? I don't care which way you do it. Raymond, if it were me, I would do this. But this is more of like what I showed you in class as far as following more of a procedure. Questions on that? All right, we only have one of them. Now we need the y-intercept, right? So for the y-intercept, Cambry?
Yeah.
All right, you've got the y-intercept.
Okay.
Well, yeah, it's gone. All right. So for the y-intercept,
X is going to be 0.
Okay.
So negative 3x times x is going to be 0, 0, 2y equals 4.
okay, 2y equals a fourth.
I would divide the 2.
Divide the 2. Okay. So when you do that, you want me to write like this, like divide 2 here and then do the same thing over here? Okay, so divide by 2. This will become a y. And this is what I'm curious about, Cambry. Like, how do you do that?
When I get to that point, I basically switch it around so I have the 1/4 times 2 over 1.
Okay, yes, I'm with you. So look, this part right here is where students get messed up, all right? Right at this step right here. So the way I want you to think about this is a big division bar, okay? And this on the bottom is a 2 over 1, all right? And then look at it like this. You're really doing 1/4 divided by 2 over 1, right? That's really what you're doing, which is the same as 1/4 division becomes keep dot flip. Remember that? So keep it, dot it, flip it. And then multiply across.
Yeah, that's okay.
Okay, you see that? You see why now? Okay. Everyone good on that? So what would this be, Cambry?
1 over 8.
1 over 8, 1/8. That's clear? Anyone need me? I forgot to put over here on the x-intercept, I forgot to put the point, write it as a point. Negative 2/3, 0. And then on this one, the y-intercept, we're going to have 0 for the x and 1/8 for the y. Are we good? All right, so now we draw it. The drawing of this is going to be weird. The drawing of this is going to be weird. Because we've got these fractions, right? So you kind of have to have an idea of where these things live. Like, I think, well, 1/8, take 1, cut it into 8 pieces. 1/8, really small. 2/3, but negative. So let's just do it. So when I go to draw this, watch what I'm going to do. Because I know I'm dealing with fractions, my x-intercept is at negative 2/3. Over here, I'm going to put negative 1. See how big I'm making it? And that way I can fit in here. Like, this is 1/3. If I cut this into 3 equal pieces, right, this right here would be negative 2/3. This would be negative 1/3, negative 2/3, and then negative 1. That's my x-intercept. And then my y-intercept is 1/8, right? Positive, so I need to go up 1/8. So I'm going to say this is 1 here. 1/8 is going to be way down here. You're just going to eyeball it. It doesn't have to be perfect. Would you all agree, though, it's pretty far down here? 1/8? Put a dot here. Connect them with a straight line. Questions? Fractions can be a little messy. All right, let's do a new one. Ready for this one? All right. What? So we've been talking about linear equations in two variables, right? And I want you to sketch this. Well, this right now does not look like a linear equation in two variables, does it? It doesn't look like it has two variables. But I'm asking you to sketch it, which means I want you to draw this as a line. What? Okay, so think about this. If I go to my x-axis and I go to -2, and I pick that point right there, that is the point -2, 0. Agreed? Would you agree that that point satisfies this equation? That the x-coordinate is -2, right? And this says nothing about the y-coordinate, right? It doesn't give me any sort of restriction on the y-coordinate. So as long as the x-coordinate is -2, that point would actually be good, like it would satisfy that. But it would work for any point that I pick that has an x-coordinate of -2. So I could have picked, I don't know, let's go up 1, let's go over here, let's do this point. That's the point -2, 1, right? That would also satisfy that equation, wouldn't it? Because the x-coordinate is -2. And I could do that for any point that lies over there, right? On a what? On a vertical line. So if I draw a vertical line like this, that is the solution, that is the line that represents that equation. So if you ever have an equation, you're asked to graph it and it just has the variable x equal to a number, you're going to go to the x-axis, draw a line, draw a dot on the x-intercept, and then draw a vertical line. So this is basically what I'm telling you, is that this is the equation of a vertical line. What do you think the equation of a horizontal line is? Yeah, y equals a number, right? So let's do that. How about y equals 3? If I give you that and I say, hey, sketch this line. Well, you go through the same process. You say, okay, well, y has to be 3. So I go up 1, 2, 3 on the y-axis, put a dot here, right? That's y equals 3. And then any point that I pick that has a y coordinate of 3,